Okay, are you getting screen? Hello? Hello? Somebody can reply.
Yes, sir.
Huh? Hello?
Visible, sir, but not clear.
Visible but not clear. Okay. Then last lecture. Okay. Last lecture, I think we have started the heat losses in the boiler plant. So, who will tell about the background related to heat losses related to boiler plant? Anybody? Okay. Heat losses means efficiency of boiler plant in each and every numerical we have solved is up to, in some cases it is 89% one case, but normally efficiency of boiler is up to 60 to 70%. And what this indicates? What this indicates? Anybody? Suhas, Kunal?
Some amount of it always go in the form of losses.
Okay, some amount of it always go in the form of heat losses. So there are several heat losses occurs in the boiler plant. Out of that, some important heat losses today we are going to take into consideration. Okay. Now, first heat loss on that day we have completed is which heat loss? Anybody?
Heat
First
loss
heat
by
loss.
dry flue gases.
Okay, heat lost by dry flue gases. So whatever the exhaust flue gases are there in the boiler, first of all they will heat the water. That water is get converted into steam, and these flue gases or hot gases we are exhausting into the atmosphere. So while leaving the chimney, at the chimney end, these gases are going to be escaped from the boiler. And at the chimney end, though we are escaping them, some amount of heat is with them, because all amount of heat they cannot give to this, to the water, so that water can be converted into steam. So at that point, at the chimney end, the heat gases, the flue gases are carrying some amount of heat, and they are carrying to the atmosphere. So that will be act as one of the loss for us, and that loss we are going to calculate with the formula. Anybody that they were given that formula also to you. So that formula is, anybody?
Q, Q1 is equal to mg CPG
Okay.
into TG minus TA.
Okay. Q1 is equal to mg, correct na? mg cpg into bracket tg minus ta. And what is mg? Who will tell other than Kunal or Suhas?
Mass of dry flue gases.
Mass of dry flue
Dry
gases per kg of fuel. So how many fuel kg of fuel we have burned here? Out of that here, per kg of fuel burn, how many flue gases are coming out? Okay. So mg cpg. Cpg is what? Specific heat at constant pressure for dry flue gases is the cpg, and tg is, you tell tg is equal to temperature of flue gases leaving the chimney. So at the chimney, what is the temperature of the flue gases? Because We are recording that at chimney end. And then Ta is a atmospheric temperature in boiler house, or it is called as what, boiler room temperature. And whatever the heat losses occurs in the boiler plant, out of that the major heat loss is the heat losses due to dry flue gases. Write down in your notebook. It is, last note, you make note and write down. It is it is the major heat loss, it is the major heat loss occurs in the boiler plant. It is a major heat loss occurs in the boiler plant. Okay, so in MCQ, many times, they are going to ask, in MCQ they are going to ask many times that here the heat, the which heat loss is the major heat loss which occurs in the boiler plant, which heat loss is major heat loss in the boiler plant. So what will be answer? Somebody, what will be answer for this? Anybody?
Heat loss by dry flue gases.
Heat loss by dry flue gas. And how it is calculated? Mg Cpg into bracket Tg minus Ta. Okay, now screen is available, blank screen.
Yes, sir.
Okay, now here second heat loss, write down heat loss number 2 with me. So because now that book is not visible to you, I will write. Okay, will invest some more time. Write down heat lost, next heat loss is heat lost heat lost due to due to conversion heat loss due to conversion of water in bracket moisture in bracket moisture in the fuel in the fuel into steam. Okay, into steam. Okay, Rahul Gaikwad, roll number 5. Rahul Gaikwad,
Yes,
is
sir.
it visible to you that loss? Rahul,
Yes, sir.
okay, is it visible?
No, sir.
No, that screen is not visible to you. What have I written?
No, sir.
No, sir.
Huh? Somebody telling yes, somebody no. Huh? Oh, what is the problem? Okay, one minute. Huh? ठीक है. Is it visible now?
Yes, sir, visible.
Yes, sir. Visible.
Okay. So right. Okay. Have you written that heat second heat lost is heat lost? Okay. Heat loss due to conversion of conversion of water in bracket moisture in the fuel into steam. Okay. So what is here is that every time we are not getting dry fuel. So whatever fuel we are burning in the boiler is generally coal or wood, okay, or some solid waste. Okay, so these fuel, whatever these fuels we are burning in the boiler, maybe coal, wood, or solid waste, contains some water particles or moisture in that fuel. And when such fuel is burned in the combustion chamber, what will happen? Whatever water part is there of that particular fuel, take the heat during the combustion and it is converted into steam. But what do we expect? Which water should be converted into steam? Anybody? Somebody? Are you getting? So which water? Which water? Whatever the water is there in the boiler shell or drum, that water we want to convert into steam. But what happens? The water or moisture present in that fuel take the heat during combustion and it is converted into steam. But that steam we are not utilizing for any purpose. So that is acting as a loss for us. Everybody agree? Keep it as Suhas, Rushikesh.
Yes, sir.
Okay. So whatever the fuel is there in the moisture is there in the fuel, it is converted into steam. That will be act as loss because for that conversion we have that heat is taken from the combustion, and therefore our actual conversion it that heat will be less, and that is acting as a heat loss. Write down. Moisture is present. Moisture is present. Moisture is present in the fuel. Moisture is present in the fuel, comma, when fuel burns, when fuel burns, 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 this moisture takes, this moisture takes, this moisture takes heat from the combustion, heat from the combustion, heat from the combustion, and converted, and into, converted into superheated steam, converted into superheated steam. Full stop. This loss, full stop. This loss is calculated by the following formula. By the following formula. By the following formula. Write down. Next line. Q2. This loss we will call it as what? Q2 is equal to MW into bracket. Now whatever steam is there is converted into superheated steam because that moisture is present in the fuel combustion. So it will take a lot of amount of it and it is converted into superheated steam, and that quantity of moisture is also less as compared to our quantity of water in the boiler. So moisture quantity is less and that is converted into what? Superheated steam. So and in the boiler conditions are atmospheric condition because boiler room combustion chamber is there where pressure is only atmospheric pressure. That heat is carried in the drum. In the drum, the pressure of boiler, whatever we want to convert the steam of that pressure is in the drum or shell. But where we are burning the fuel, there everything is atmospheric. So pressure is atmospheric. Temperature means what? Boiling temperature will be atmospheric. I mean at atmosphere, water boils at 100 degrees Celsius. So saturation pressure is 1 atmosphere and saturation temperature is here 100 degrees Celsius. 100 degrees Celsius. Okay. So it can be calculated MW, mass of water moisture present per kg of fuel. Okay. Then how we are calculating the formula? Superheated steam enthalpy Hg at 1 atmosphere. Write down Hg at 1 atmosphere plus, okay, specific heat of steam because it is superheated steam, okay, and having temperature, whatever the temperature of the here steam leaving the chimney, that we are considering T superheated, minus saturation temperature at boiler condition, it is T saturated at 100 degrees Celsius. Okay, okay, so this, and definitely this is a MW, okay, and initially that moisture is having some enthalpy HW. So this is the amount of heat, okay, HW. So with the help of this formula, one can calculate the heat loss due to conversion of water moisture in the fuel into steam. Okay. But Hg at 1 atmosphere, we know. What is that value? Anybody? Now steam table we have to go for that. Okay. And for that steam table we know. Okay. So steam table Hg, it is at 1 atmosphere. So table number, who will tell the value? Hg at 1 atmosphere. Okay. And saturation temperature at 1 atmosphere is 100 degrees Celsius. That two values we have to confirm from the steam table. So table number 2, because now pressure we know 1 atmosphere. So say 1 to 14 table number we have to go for. Okay. Is it visible, steam table? Now 1 atmospheric pressure is how much? Nearly equal to 1 bar, or exact value I have told. It is what is that exact value of 1 atmospheric pressure? Who will tell? Exact value of 1 atmospheric is, anybody? Already I have defined it.
1.01325.
1.01325 bar. Okay. And here, what is saturation temperature at 1 atmosphere? Ts. From the, this is saturation temperature. If you will go for that column heading, okay, it is Ts means temperature, means it is saturation temperature. Okay. So 1.01325 bar. Okay. What is saturation temperature? Ts is 100. And what is Hg value? Okay. So it is HF, it is HFG, HF, HFG and HG. So Hg value, this is the column of Hg. Okay, at 1 atmosphere, it is what value? 2676. Now who will tell? Atmospheric pressure, saturation temperature is, somebody can help me?
100 degrees Celsius.
100. And what is
100 degrees
Hg value?
Celsius.
Okay, 100. And Hg value is 2676
2676.
kilojoule per kg. Now here we have to put the value. Okay, therefore this Q2 is coming as the heat loss due to conversion of water moisture present in the fuel into steam. Which steam? It is generally converted into what? Superheated steam. MW into bracket. So this is Hg at 1 atmosphere is 2676 plus CPS, specific heat of steam at constant pressure. Okay, and T soup is that temperature will be taken from the numerical. Okay, minus T sat. Okay, T sat here is will be 100 and minus HW, enthalpy of feed water. or moisture. What is the boiler room temperature is there? That boiler room temperature, water will be available, and that HW is there. It is HW is equal to HF at boiler room temperature. Okay. Now everybody got this? What is Q2? Heat loss due to conversion of water in bracket moisture in fuel in the fuel into steam. That is, steam is superheated. Therefore, Q2 is equal to MW into bracket 2676 in plus CPS into bracket T SU minus T sat at 1 atmosphere is 100 minus HW. You already got? Written? Written?
Yes, sir.
Okay. Shall I give nomenclature for each and every word? What is here in noting points? Okay, write down. Where MW is equal to mass of water moisture present, mass of water moisture present, mass of water moisture present per kg of fuel, per kg of fuel, per kg of fuel. Then write down CPS. CPS is what? Mean specific heat, mean specific heat, mean specific heat of steam, mean specific heat of steam at constant pressure, mean specific heat of steam at constant pressure, mean specific heat of steam at constant pressure. Then T soup is temperature of superheated steam, temperature of superheated steam. Then HW is equal to specific enthalpy, specific enthalpy of moisture, specific enthalpy of moisture, specific enthalpy of moisture at boiler room temperature, at boiler room temperature. Now, that is HW is equal to HF at boiler room temperature. It is not the HF at feed water temperature. It is what? HF at boiler room temperature. HF at boiler room temperature. Everybody got this loss formula? What is this loss and what is formula to calculate the loss? Because many times they are asking theory question on this. Write or explain the different heat losses occurs in boiler plant with formulae. Okay, now everybody second loss, everybody got second loss. Anybody having problem about second loss? Yes, good. Okay, so shall I ask somebody, Kunal, to repeat this loss?
Yes, sir.
Okay, repeat. Slowly repeat so that everything you have written in your notebook.
Heat loss due to conversion of water in the fuel
Okay.
into steam.
Okay.
Moisture is present in the fuel. When fuel burns, this moisture takes heat from the combustion and converted into superheated steam. This loss of heat can be calculated by Q2 is equal to MW into Hg plus CPS into T soup minus T sat minus HW.
minus HW.
Uh,
Okay, but Hg value at 1 atmosphere is
Q2 is equal to
hmm,
2676
okay, plus
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 CPS
CPS
into T soup minus 100 plus CPS into T soup minus 100
minus HW minus
where MW is equal to,
HW.
yes sir,
Okay,
minus
okay, we got it.
HW
Okay,
where
okay, okay. Next loss, third loss. Ah, you are losing contact, I think, sir. Kunal. Okay, next loss, write down. Third heat loss, third loss, third loss, write down. Heat lost, heat lost, heat lost by water, heat lost by water, heat lost by water due to due to combustion of H2 due to combustion of H2 per kg of fuel, per kg of fuel, per kg of fuel. Okay, what is that? Heat lost by water due to combustion of H2 per kg of fuel. This is loss number 3. Okay, so what is this loss? So it is similar to our earlier loss. What are the earlier loss? Conversion of water in bracket moisture into steam. So similar to that, what happens that in fuel means what? It is hydrocarbon, mixture of carbon and hydrogen. Okay, fuels are generally what? They are mixtures of what? Carbon and hydrogen. For example, methane you take. Example is what? Methane. You take methane. Then methane. What is methane? Or here methane. What is formula? It is hydrocarbon. Fuels are hydrocarbon. For example, methane you take CH4. Okay. If it is ethane, then it will be anybody C2. If it is methane, what is the formula? Chemical formula of methane? Fuels are generally hydrocarbons. They contains carbon as a major constituent element and hydrogen as a minor element. They are hydrocarbons. Methane is CH4. Ethane is anybody?
C2H6.
C2H6. Correct. So when these hydrocarbons make go for combustion process, means they will react with combustion is nothing but what? Oxidation reaction. When they will react with oxygen, what will happen generally? Anybody? If pure combustion, if you say, what will happen when they will oxidized? Fuels are oxidized, hydrocarbons are oxidized. Anybody? Carbon react with oxygen to form CO2. Correct? Carbon reacts with oxygen to form Ca2, and hydrogen also react with oxygen to form a H2O. That is water. 2H2O. Then this is the basic. When the here fuels are oxidized or combusted, what will happen? Carbon in the fuel react with oxygen to form CO2. Hydrogen in the fuel react with oxygen to form So this is going to be had to form H2O. Similar to this C2H6. So only things is there we have to balance the reaction. So here we can say CH4 carbon is balanced, hydrogen is balanced, O2 is 2O2 plus 2O. Here we have to go for 2O2. So this is a balanced reaction. So CH4 plus 2O2 gives CO2 plus 2H2O. So means I want to show here is that when in the combustion fuels are hydrocarbons, and during the combustion hydrogen in the fuel react with oxygen to form H2O. And whatever this water is formed during the combustion, what will happen? This water will be again, it is act as a moisture. It will take the heat from the combustion and it is get converted into superheated steam. That is also acting as a one of the loss. Everybody understand this? How hydrogen is, first of all, hydrogen in the fuel here is get combusted and formed water, and that water immediately absorb the heat from the combustion, and that water is converted into what? Superheated steam. And that, but this is acting as a loss for us. Okay, write down now. Next line. Okay, is it over? Everybody written example here heading, then write down. Hydrogen present in the fuel, hydrogen present in the fuel reacts with oxygen, hydrogen present in the fuel react with oxygen during combustion, during combustion, during combustion, and converted, and converted into water, converted into water. Full stop. This water, this water also takes, this water also takes heat. This water also takes heat, HEAT, heat from the combustion, from the combustion, and get converted, and get converted into superheated steam, get converted into superheated steam. Full stop. This loss is also, this loss is also can be calculated as, can be calculated as same formula there. Okay, next line, Q3 is equal to 9H2, 9H2, 9H2 in bracket, 9H2 in bracket, same formula of conversion of water moisture into steam, same formula, 2676. हाँ 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 हाँ, आता ते आपल्याला यादी पाहिजे काय काय आपल्याला. बोरे मॅडम आले आपण लिस्ट दिली, आपण 3 वाजता बसू सगळं. हा ठेवा वाट काय प्रॉब्लेम, ठेवा आपण त्या लेक्चर संपलं की एक अर्धा तास बसू म्हणजे बघूया काय आपल्याच काम आहे सगळ्यांचं. शिवाय तर घेऊन या 3 वाजता, बघा तुम्ही काय करा. पण आता मी लेक्चर काय ही करू चालू आहे, 3 सव्वा 3 वाजता या. कुठल्या बोलू त्यांना आपल्या पण काय बघू आपण आहे का काय काय राहिले. 9H2 into bracket 2676 plus PPS into bracket. So because only is present is only thing is that only hydrogen is converting into water, and that water again is converted into steam. So see in bracket T soup minus 100, okay, minus HW. Okay, so with the help of this formula, same formula is there, one can calculate the heat lost due to water, due to conversion of water, due to combustion of H2 per kg of fuel. You understand? I don't know. Where H2 is equal to H2 is equal to what is this H2? Mass of hydrogen, mass of hydrogen H2, hydrogen or H2 present present per kg of fuel, per kg of per kg of fuel. Per kg of fuel. Mass of H2 present per kg of fuel. Okay. Everybody understand this loss? Only thing is that instead of MW, we are writing here 9H2, and H2 is what? Mass of H2 present per kg of fuel. So 9H2 into bracket 2676 plus CPS into bracket T soup minus 100 minus HW. Anybody having problem? Everybody understood this loss? Anybody write yes or not, like previously? Previously you were doing. Previously you were doing. Okay, some I think only two at least. Okay, Shubham, Kunal. Okay, okay, good, good, good. So formula. Now I will repeat. I will ask somebody to explain. So I will request Suhas now. Okay, Suhas to explain.
Heat lost by water due to combustion of H2 per kg of fuel. Hydrogen present in the fuel react with oxygen during combustion and converted into water. This water also takes heat from the combustion and gets converted into superheated steam. This loss can be calculated by formula Q3 9H2 2676 plus CPS T sub minus 100 minus HW, where H2 is equal to mass of hydrogen present per kg of fuel.
सकाळच्या 21 सकाळची ओढून टाक हे जेवण करून हॅलो or
Sir,
good.
or
Okay, okay, then next loss. Loss number 4. Right now, heat loss due to heat loss due to heat lost due to incomplete heat loss due to incomplete combustion heat loss due to incomplete combustion due to insufficient air supply. Heat loss heat lost due to heat loss due to heat loss due to incomplete combustion of heat loss due to incomplete combustion due to insufficient air supply. What happens? For the combustion of fuel, we require sufficient amount of air, or sufficient amount of oxygen. So, but in some cases, if air supply is less, then there will not be a complete combustion. So, if the combustion is complete, there are only two products of combustion. One is what? Carbon dioxide. Carbon is reacting with oxygen to form carbon dioxide, and hydrogen reacting with oxygen to form H2O when combustion is complete. But due to some insufficient air supply, here there will be some carbon dioxide will not be formed. So instead of carbon dioxide, here some quantity of carbon monoxide is formed. Instead of formation of CO2, what will form? Complete here some moles will be converted into what? CO. That is what? Carbon monoxide. And due to this, here what happens? Here the combustion heat of carbon dioxide, whatever heat is going to be produced, it is more. And carbon monoxide, the combustion heat is what? Low. So this difference, if it is complete combustion is there, heat generated heat during the combustion is always more. If complete combustion will be there. But if carbon monoxide is get formed, then heat generated during the combustion is always less. And this difference, that is combustion, okay, this difference, that is combustion heat of here CO2 and combustion heat of carbon monoxide. So this difference will be act as a heat loss for us. Okay, write down now. Due to due to insufficient air supply, due to insufficient air supply for combustion, due to insufficient air supply for combustion, due to insufficient air supply for combustion, carbon monoxide, carbon monoxide in bracket CO, carbon monoxide in bracket CO is formed, carbon monoxide in bracket CO is formed instead of CO2, instead of CO2, instead of CO2. Full stop. The combustion heat of the combustion heat of CO, the combustion heat of CO is less. The combustion heat of CO is less as compared to CO2, as compared to combustion heat of CO2, as compared to combustion heat of CO2, as compared to combustion heat of CO2. Next line. This loss, this loss can be calculated as, next line, Q4 is equal to, next line, MCO, means mass of carbon monoxide, MCO into bracket combustion heat of CO2, combustion heat of CO2, combustion heat of CO2, combustion heat of combustion heat of CO2 minus combustion heat of combustion heat of CO, combustion heat of CO. With the help of this formula, one can calculate the heat loss due to incomplete combustion due to insufficient air supply. Okay, everybody understand? Mention, reply. Everybody understand? Okay. Now Gaurav Karande. Okay, after a lot of time I'm asking you, Gaurav, repeat this heat loss for all information, everybody's information. Gaurav Karande.
Yes, sir.
Okay. Uh,
Heat loss due to incomplete combustion due to insufficient air supply.
okay. Continue.
Due to insufficient air supply for combustion of carbon monoxide form instead of CO2. The
Okay.
combustion heat of CO less than combustion heat of CO2. This loss can be calculated as Q4 is equal to MCO in bracket combustion heat of CO2 minus combustion heat of CO.
Correct. Good. Where? I don't know. Where MCO is equal to, very good, Gaurav. MCO is equal to, MCO is equal to mass of CO. It given na mass of CO present, mass of CO present, mass of CO present per kg of fuel, mass of CO present per kg of fuel. Mass of CO present per kg of fuel. With the help of this formula, one can calculate the heat loss due to incomplete combustion due to insufficient air supply. Okay. Next loss. Add on the loss number 5. Okay. Now add on loss number 5. Okay. Heat loss due to heat loss due to heat loss due to unburned fuel. UNBURNT, unburnt fuel. Heat loss due to unburnt fuel. Okay, right now. Next line. Some amount of fuel, some amount of fuel, some amount of fuel remain unburnt, some amount of fuel remain unburnt in the form of ash. Some fuel remain unburnt in the form of ash. The calorific value, the calorific value of unburned fuel, the calorific value of unburned fuel is not utilized, is not utilized to convert, is not utilized to convert water into steam. The calorific value of unburnt fuel is not utilized to convert water into steam. Okay, next line. This loss is calculated. This loss is calculated is equal, next line is equal to Q5 is equal to MF1. Very simple formula is MF1 into CV1. MF1 into CV1. Only this simple formula here. This loss can be calculated. What is that? Heat loss due to unburnt fuel. Though we do combustion, etc., but some amount of ash is remained as a unburnt fuel, and that fuel is carrying some amount of calorific value or heat, and that heat is not utilized to convert water into steam. It remained in the that combustion chamber itself. So that heat is acting as a loss for us, and it is called as heat loss due to unburnt fuel. And it can be calculated by formula MF1 into CV1. Right on. Where MF1 is equal to mass of unburnt fuel mass of unburnt fuel mass of unburnt fuel per kg of fuel per kg of fuel means MF1 divided by MF, and right on CV1 is equal to here I don't calorific value of unburnt fuel. Calorific value of unburnt fuel. Okay, so this loss is very simple, but it is always asking in the examination because in the numerical, because we are having the heat balance sheet we have to draw for only 5 to 6 marks, and there only they are not going to ask the complicated losses, they are going to ask only simple losses to draw the heat balance sheet. So here there it may appear. Hold on, who will tell now? Everybody understand? Reply. Everybody understand? Okay, good. Now I should ask whom Kunal was there knowing, Gaurav also knowing. So shall I call Shubham Gandule? SY02. Shubham, for everybody's information, can you read? Slowly read. Okay.
It was due to
Ha,
unburnt
ha.
fuel in the form of ash. The calorific value of unburnt fuel is not utilized to convert water into steam. This was is calculated at QS is equal to MF1 into CV1, where MF1 is equal to mass of unburnt fuel per kg of fuel. CV1 is equal to
Okay. You are having range problem, but still you are defined. I think we also got it. Okay. Next, last loss. Always, if there is loss, is there mentioned or not? I don't know. Six, loss number 6. Loss number 6. Right on. Here, heat lost due to radiation. Heat lost due to radiation. Heat lost due to radiation or it is also called as or unaccounted 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 heat loss. Unaccounted heat loss. Okay. So this loss is what? Here I down. Heat loss due to radiation or unaccounted heat loss. Okay. Now what happens? First of all, understand. So boiler is a huge assembly. Boiler is a huge assembly. And what happens? Where we generate steam and where we apply the steam for a particular application, or where we use the steam, that place, and where we generate the steam, that place, is having some distance. So we have to always carry the steam from the generation point of view, from boiler to the using area. And through that also, what happens? This boiler, due to, because when we do the combustion, the boiler parts get heated, because, and these boiler parts and atmosphere, there is a temperature difference exists. There is a temperature difference exists, and due to that, what will happen? Through the radiations, boiler radiates lot of amount of heat to the atmosphere. Or what are the pipelines we use for carrying the steam? Okay, so these steam also exhaust much amount of heat to the atmosphere. Though we do insulation, but no, there is 100% insulating material is not there. So some amount of heat or some leakage of insulation is there, that wool we're using or that foam material we're using as insulation, but still some amount of heat always go into the atmosphere, because boiler is having, boiler parts are heated. These radiates in the heat in the form of losses, and this loss is called as heat loss due to radiation. But there is no formula to calculate this loss. Only by mathematical way, or by taking heat balance into consideration, one can calculate the heat loss due to radiation or unaccounted loss. Write down now. Next, write down first, then I will explain. Write down. It is also called as, it is also called as, it is also called as unaccounted heat loss. It is also called as unaccounted heat loss. It is also called as unaccounted heat loss. Many boiler parts, many boiler parts, many boiler parts are exposed to atmosphere. Many boiler parts are exposed to atmosphere. Full stop. Next line. The surface of boiler, the surface of boiler radiates energy. The surface of boiler radiates energy in the form of heat loss, in the form of heat loss to the atmosphere, in the form of heat loss to the atmosphere. Full stop. THERE, there, THER, don't write THEIR, there, THERE, there is no specific formula, there is no specific formula to calculate, to calculate the heat lost due to radiation, heat loss due to radiation, heat loss due to radiation. Hence, it is termed as, hence it is termed as unaccounted heat loss. Hence, it is termed as unaccounted heat loss. Hence, it is termed as unaccounted heat loss. Full stop. It can be calculated. It can be calculated. It can be calculated by using heat balance, by using heat balance of a boiler. Heat balance of a boiler. मीन्स व्हॉट, म्हणजे काय तर जेवढं आपल्याला हीट दिलेली माहित आहे, हीट सप्लाइड माहित आहे किती केलेली आहे, मास ऑफ फ्युएल बर्न इनटू कॅलरी ऑफ व्हॅल्यू, त्यातली काही अमाऊंट ऑफ हीट स्टीम वॉटर घेणार आणि दॅट इज कन्व्हर्टिंग इनटू स्टीम. आणि जेवढे जेवढे लॉसेस आपल्याला माहित आहेत, जेवढे जे आपण कॅल्क्युलेट केले आहेत, तेवढे लॉसेस आणि हीट युटिलाइज्ड याची बेरीज हीट सप्लाइड म्हणून केल्यानंतर जो डिफरन्स राहील त्यालाच आपण काय म्हणतोय, हीट लॉस्ट ड्यू टू रेडिएशन. आणि म्हणजे त्याचं फॉर्म्युला नाहीये, कारण भरपूर पार्ट्स आहेत बॉयलरचे, भरपूर मोठा बॉयलर आहे आणि त्याचं किती पार्ट, कुठला पार्ट किती हिट झालाय, कुठल्या पार्टला टेम्परेचर किती आहे, तेवढं आपल्याकडे डिटेल कॅल्क्युलेशन नसल्यामुळे आपण काय करतो, दिस लॉस वी आर कॅल्क्युलेटिंग बाय फॉर्म्युला, बाय इम्पेरिकल फॉर्म्युला. मीन्स हीट सप्लायड मायनस काय करणार आपण, आता एवढी सप्लाय केली त्यातली काय हीट युटिलाइज्ड फॉर कन्व्हर्टिंग वॉटर इन टू स्टीम प्लस समेशन ऑफ ऑल रिमेनिंग हीट लॉसेस. सगळे याच्या आधीचे सगळे लॉसेस आणि हीट युटिलाइज्ड फॉर कन्व्हर्टिंग वॉटर इन टू स्टीम याची बेरीज हीट सप्लाइड म्हणून केल्यानंतर जी क्वांटिटी राहील त्याला आपण काय म्हणतोय, अनअकाउंटेड हीट लॉस. डाउन नेक्स्ट लाइन. It can return, it can be calculated as next line, Q6 is equal to काय, तो Q6 is equal to QS म्हणजे हीट सप्लाइड मायनस, आता काय हीट सप्लाइड केलेली काय करतो आपण, पहिल्यांदा आपलं एम काय आहे, वॉटरचं रूपांतर स्टीम मध्ये होण्यासाठी, म्हणजे त्याला आपण म्हणू Q. ओके. आणि आतापर्यंत काय केले आपण, किती लॉस फरक केले, ह्याच्या आधीचे 5 लॉस, त्याचे फॉर्म्युले आपल्याकडे आहेत. म्हणजे इथे एक आपण इन जनरल म्हणतोय Q प्लस Q1 प्लस Q2 म्हणजे वॉटरचं रूपांतर स्टीम मध्ये करायसाठी लागणारी हीट वॉटरने घेतलेली इफेक्टिव्ह, हे आपली म्हणजे इफिशियंट हीट आहे. आणि हे सगळे लॉसेस आहेत, Q1 प्लस Q2 प्लस Q3, आपल्या आता सध्या केसमध्ये काय प्लस Q4 प्लस Q5 किंवा इन जनरल काय म्हणू शकतो आपण, Q6 इज इक्वल टू सर Q6 is equal to what we can say, QS minus in bracket काय येणार, Q प्लस समेशन ऑफ जेवढे आपल्या न्यूमेरिकल मध्ये लॉस दिले तेवढे, समेशन ऑफ ऑल रिमेनिंग लॉसेस. ओके, 2 मिनिटं बस आहे, 2 मिनिटं. ओके, का 10 मिनिटांनी येत आहे. हां ओके. Q6 इक्वल टू QS मायनस इन ब्रॅकेट Q प्लस समेशन ऑफ ऑल रिमेनिंग हीट लॉसेस. त्याच्यामध्ये काय आहे आपलं, व्हॉट इज QS, QS इज इक्वल टू हीट सप्लाइड टू द बॉयलर, total heat supplied to the boiler per kg of fuel it is that heat supplied to the boiler. Heat supplied to boiler. Heat supplied to boiler. And what is Q? हे इफेक्ट युटिलायझेशन, हे Q काय, हीट युटिलाइज्ड to convert water into steam. ओके, एव्हरीबडी गॉट इट. म्हणजे जी राहिलेलं हीट सप्लायड आणि हीट युटिलाइज्ड आणि लॉसचे ऍडिशन केल्यानंतर ते सगळं ह्या फॉर्म्युल्यामध्ये राहिल्यानंतर जी काही राहील त्याला आपण काय म्हणतोय, हीट लॉस ड्यू टू रेडिएशन किंवा हीट लॉस, इट इज अनअकाउंटेड हीट लॉस. म्हणजे आपल्याला काढता येत नाही, म्हणजे आपण काय म्हणतो अनअकाउंटेड. जे आपल्याला फॉर्म्युला नाहीये असा लॉस. ओके, एव्हरीबडी अंडरस्टँड? दिस इज लास्ट लॉस. एव्हरी न्यूमेरिकल दिस लॉस वी हॅव टू कॅल्क्युलेट. Others, depending on condition, information given in the numerical, others we have to consider. But this loss number 6 always we have to consider in each and every numerical. Understand? जे राहिलेलं आहे सगळं ते heat loss due to radiation. Reply. Okay. Others only Gaurav and Rushkesh. Okay. Okay. Now I want one volunteer to read this from girls side now. Anybody from girls at own? They can unmute and tell the loss. This is information about loss. Any girl up to 1.5 hour. No girl has interacted. So anybody from girl side, or they want that I should take their name and they should come for. Okay, roll number.
Yes,
Okay, good, very good. Initiative taken by one. Who is your name? I'm not getting here on screen. Okay, Rutuja. Good, good, Rutuja. Tell Rutuja. Have you understood this loss?
yes, sir.
Okay, good. Very good.
Heat loss due to radiation or unaccounted heat loss.
Okay.
It is also called as unaccounted heat loss. Many boiler parts are exposed to atmosphere. The surface of boiler radiates energy in the form of heat loss due to atmosphere. There is no specific formula to calculate heat loss due to radiation. Hence, it is termed as unaccounted heat loss. It can be calculated by using heat balance of boiler. Q6 is equal to Qs minus into bracket Q plus Q1 plus Q2 plus Q3 plus Q4 plus Q5 bracket complete.
Okay, means general Q6 is equal to Qs minus Q plus summation of all remaining heat losses. म्हणजे Q आणि लॉस ची ऍडिशन QS मधून सप्लाय वजा केल्या, QS मधून वजा केल्यानंतर जो राहील तो आपला Q6 म्हणजे हीट लॉस ड्यू टू रेडिएशन. आणि ह्याला QS ला आपण काय म्हणतोय? हीट सप्लाय टू बॉयलर. आणि Q ला काय म्हणतोय आपण? हीट युटिलाइज्ड टू कन्वर्ट वॉटर इंटू स्टीम. म्हणजे आपण स्टीमचे HS हे आपण न्यूमेरिकल मध्ये आपण घेऊया. आपण लक्षात आलं? ओके. Then last article of theoretical article for this is a next line. Write down heat balance sheet. Write down heat balance sheet of a boiler. Heat balance sheet of boiler. Heat balance sheet of a boiler. Heat balance sheet of boiler. Okay. आधी लक्ष द्या. What is this heat balance sheet of a boiler? तर बॉयलरला आपण किती हीट सप्लाय केली आणि बॉयलर पासून ती कशी युटिलाइज केली गेली, त्या ही जी आपण ह्या ज्या दोन हीट सप्लायड आणि हीट युटिलाइज्ड कशी झाली याचा जो टॅब्युलर फॉर्म आहे त्याला आपण काय म्हणतो? हीट बॅलन्स शीट ऑफ ए बॉयलर. समजलं काय? एखाद्या बॉयलरला किती अमाऊंटची हीट सप्लाय केली गेली आणि त्या बॉयलर कडून कशी ती युटिलाइज झाली गेली, कशी ती वापरली गेली, याचं जे टॅब्युलर पद्धतीचं जे रिप्रेझेंटेशन आहे टेबल फॉर्म मधलं याला काय म्हणतो आपण? हीट बॅलन्स शीट ऑफ ए बॉयलर. पण हीट बॅलन्स शीट ऑफ बॉयलर नंतर आपल्याला काय कळतं की बॉयलर मध्ये किती हीट सप्लाय होते, त्यापैकी किती हीट बॉयलर वॉटर घेतोय आणि ते स्टीम मध्ये रूपांतर होते, म्हणजे इफेक्टिव्हली किती हीट घेतली जाते, म्हणजे बॉयलरची इफिशियन्सी आपण काढू शकतो हीट बॅलन्स शीट वरून. नंतर एखाद्या लॉस मध्ये म्हणजे मेजर हीट लॉस ड्यू टू ड्राय फ्लू गॅसेस, ह्याचा हीट लॉसची क्वांटिटी किती आहे, त्याचं पर्सेंटेज किती आहे, ते आपण काय करू शकतो, वी कॅन गेट फ्रॉम द हीट बॅलन्स शीट. म्हणजे वेगवेगळ्या हीट लॉसेस मध्ये किती हीट वाया जाते, किती हीट, त्याचं पर्सेंटेज किती आहे त्या लॉसचं, दॅट वी कॅन गेट विथ द हेल्प ऑफ दिस हीट बॅलन्स शीट. म्हणजे आपल्याला काय होईल, एखाद्या हीट लॉस मधून जास्त हीट जर जास्त जात असेल तर आपल्याला कळतंय बाबा ह्या सिस्टीम मध्ये, म्हणजे एखाद्या हीट कॅरीड अवे बाय ड्राय फ्लू गॅसेस ही जास्त आहे, 40% आहे. तर आपण एखादी सिस्टीम डेव्हलप केली आणि ती हीट लॉस ड्यू टू ड्राय फ्लू गॅसेस जरा आपण कमी केले, त्यातली हीट कमी केली, समजा 20%वर आणली ती लॉस, तर डायरेक्टली 20% काय होईल, काय होईल एनीबडी, हीट लॉस ड्यू टू ड्राय फ्लू गॅसेस आपण जर कमी केले, 40%वर आपण 20% आणले, तर 20% आपली काय वाढेल, एनीबडी काय वाढेल, कोण पण सांगा,
Efficiency.
इफिशियन्सी वाढेल. म्हणजे बॉयलरची इफिशियन्सी कशी वाढवायची किंवा बॉयलर, हाऊ टू मेक बॉयलर इफेक्टिव्ह, हे जर करायचं असेल तर आपल्याला त्या बॉयलरची काय केली पाहिजे, हीट बॅलन्स शीट आपल्याला ड्रॉ केली पाहिजे. म्हणजे त्या हीट बॅलन्स शीट इज नथिंग बट परफॉर्मन्स ऑफ ए बॉयलर. तुमचा रिझल्ट टेब आहे, तुम्हाला किती मार्क पडले ओव्हरऑल, का कमी पडले, का कुठल्या विषयात कमी पडले, कुठल्या विषयात जास्त पडले, कशामुळे तुम्हाला मार्क कमी पडले, हे जर तुमचं रिझल्ट शीट कसं असते तुमचं ऍट द लास्ट, तसं हीट बॅलन्स शीट म्हणजे त्या बॉयलरचं काय एक प्रकारचा रिपोर्ट किंवा रिझल्ट असतो. एवढं अंडरस्टँड, ओके. म्हणजे ह्याच्यामध्ये कॉलम कुठले कुठले असणार, एक असणार तुमचा हीट सप्लाइड, दुसरा असणार हीट युटिलाइज्ड आणि पर्सेंटेज युटिलायझेशन. ह्या 3 कॉलमची काय असते तुमची हीट बॅलन्स शीट. ओके, राईट डाऊन फर्स्ट. ओके, नेक्स्ट टाइम इट इज परफॉर्मन्स शीट, it is performance sheet of a boiler, it is performance sheet 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 of a boiler in tabular format, it is performance sheet of a boiler in tabular format, full stop. It gives information about, it gives information about the total heat supplied, the total heat supplied to the boiler. It gives information about the total heat supplied to the boiler and 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 various ways, and various ways, and various ways by which, and various ways by which heat is utilized, various ways by which heat is utilized, and various ways by which heat is utilized, heat is utilized from the boiler, heat is utilized from the boiler, heat is utilized from the boiler. It always indicates, it always indicates, it always indicates the efficiency of boiler, it always indicates the efficiency of boiler, it always indicates the efficiency of boiler, and it always indicates the efficiency of boiler and different heat losses, and different heat losses occurs in boiler plant. हाँ सर, हाँ सर, good afternoon. In my cabin, my lecture is going on, sir. 10-15 minutes. And I come afterwards. I will come to your cabin. हाँ sir, Vankar sir, with him. Okay, thank you, sir. Thank you. I will come. नाही मला जाऊन घे, तुम्ही बोलूय ना तुझा या संदर्भात असणार तुमचं केस ते करते की त्याचं काय नाही प्रॉब्लेम, तुझं चालू बोलले ना ते करून टाकू, त्यासाठी बोलू ना गेलं का नाही लेक्चर करू मग तर तुला आता अवघड केलं सर. एक 10-15 3-10 पर्यंत जाऊ. 5 मिनिट कन्क्लूड करतो. ओके. हॅलो, आय आय एम ऑडिबल. Am I
Yes,
audible?
sir.
Yes,
Yes, sir.
sir. Yes, sir. Yes, sir.
Okay. Some official work call going on. Okay, 1 or 2 minutes. Okay. Sorry for that, because I am handling this lean administration position. Many people are coming urgently. Okay. So heat balance sheet everybody got? Okay. Next line right now. Next line. From the heat balance sheet. Next line. From the heat balance sheet. From the heat balance sheet. From the heat balance sheet. An engineer. From heat balance sheet. An engineer can get. From heat balance sheet, an engineer can get corrective measures. Corrective measures. Corrective measures for. Corrective measures increasing. For increasing the performance of a boiler. Performance of a boiler. Performance of a boiler. Next line. Full stop. Generally, heat balance sheet. Generally, heat balance sheet of a boiler. Generally, heat balance sheet of a boiler is drawn. Is drawn. DREWN. Generally, heat balance sheet of a boiler is drawn on 1 kg of coal basis. Of 1 kg of fuel basis. 1 kg of fuel basis. 1 kg of fuel basis. 1 kg of a fuel basis. Next line. I don't know. The sample of a heat balance sheet. The sample of a heat balance sheet on 1 kg of fuel basis. The sample of a heat balance sheet on 1 kg of fuel basis. The sample of heat balance sheet on 1 kg of fuel basis is given below. Is given below. Okay. Now everybody understand what is heat balance sheet? What is heat balance sheet? Everybody understand? Reply.
Yes, sir.
Yes, sir.
Okay. Now somebody can read so that I will draw heat balance sheet layout. Okay. It is called as layout. So now I request Kunal or Swaz, both of anybody is ready. Then read slowly so that I will draw the layout of heat balance sheet. Somebody, anybody of you? So heat balance sheet of a boiler is consisting of. Somebody can read what is written. What is written in our heat balance sheet?
It is
Kunal or
performance. It is
continue.
performance sheet. It
Okay.
is performance sheet of boiler
Okay, good.
in tabular form. It
Okay.
gives information about the total heat supplied to boiler and various ways by which heat is utilized from the boiler. It always
Good.
indicates efficiency of boiler and different heat losses occurred in boiler. From
Okay,
the
good.
heat balance sheet, an engineer can get corrective measure for increasing performance of boiler. Generally, heat balance sheet of boiler is drawn on 1 kg of fuel basis. The sample of heat balance sheet on 1 kg of fuel basis is given below.
Okay, good. So good, very good. Okay. So heat supplied is one of the column for the heat balance sheet. So I'll draw here. Heat supplied. The unities of heat supplied is kilojoule per kg. And second is how much heat is utilized from the boiler. Next is what? Heat utilized. Heat utilized. Again, the unit is what? Kilojoule per kg. Per kg of fuel we are burning and heat utilized kilojoule per kg. And last column, this we have to make heat supplied little bit width is medium, heat utilized more width, and afterwards last column is there. It is percentage utilization. Percentage. So heat balance sheet of a boiler consisting of three tables columns. One is heat supplied kilojoule per kg, heat utilized kilojoule per kg, and percentage utilization is there, another column. Then how we are supplying the heat for a boiler, that will be denoted by letter QS. So QS is equal to mass of fuel burned into, anybody interactive, we can tell, into calorific
CV, calorific value.
value. But we are drawing the heat balance sheet on 1 kg of fuel basis. Therefore, MF should be equal to what? MF is equal to 1. 1 kg. Only we are drawing only one small 1 kg of fuel. Therefore, QES is coming as what? Per kg of fuel, how much heat can be supplied? It is obviously calorific value. 1 into calorific value. So now, for basic heat balance sheet, we'll consider that heat supplied is only one formula we know, that is mass of fuel burned into calorific value. Mass of fuel burned 1 kg of coal or 1 kg of fuel, therefore QS is equal to 1 into calorific value. And afterwards, what we have to go for is the total. So total heat supplied. So although there is no mean, therefore here total is equal to, here, okay, so total is equal to QS. So here I am QS is equal to, total is equal to QS is equal to what is the calorific value, that quantity we have to write. If you are getting heat supplied, only one way we are supplying the heat to the boiler. QS is equal to MF into calorific value, that is MF 1 kg, and QS is equal to 1 into calorific value, that is CV. Now next is heat utilized. So first utilization is always what? Heat utilized. If you are drawing with me, you can draw heat utilized to convert water into steam. It would like to convert water into steam. Okay, and this we are calling it as a Q in our formula. This we are calling as a Q. What is formula? Q is equal to काय असते हे? Mass of steam generated. आणि त्याची एन्थाल्पी किती होती? HS. आणि किती पहिल्यांदा त्याचं वॉटर जे सप्लाय केलं त्याला होती एन्थाल्पी HW. म्हणजे QS इंटू ब्रॅकेट HS मायनस HW. म्हणजे टोटल मिळणार. आपल्याला काय करायचंय? 1 kg ऑफ फ्युएल बेसला काढायचं, म्हणजे 1 kg MS अपॉन MF. इथं प्रत्येक इथं एकच घ्यायचा आणि इथं प्रत्येक मासला लक्षात ठेवा, हीट युटिलायझेशनच्या प्रत्येक मासला आपल्याला MF न काय करायचं? डिवाइड करायचं. म्हणजे आपली हीट बॅलन्स शीट वी आर गेटिंग इन टर्म्स ऑफ we are getting in terms of here 1 kg of coal basis. इथं आपलं काय येणार? Q. Okay, heat utilized to convert water into steam, Q is equal to MS upon MF into bracket HS minus HW. Okay, आता ह्याचं इटरेशन काय येणार? Q डिवाइडेड बाय टोटल हीट सप्लाइड किती आहे? QS. म्हणजे टोटल हीटच्या किती पर्सेंटेज युटिलाइज झाली? Q ही आपली Q डिवाइडेड बाय QS इंटू 100. हे झालं तुमचं हीट युटिलाइज टू कन्वर्ट वॉटर इन टू स्टीम. ओके, मग आतापर्यंत तुम्ही एवढीच राहू द्या आणि पुढच्या लेक्चरला आपण कंटिन्यू करू. एव्हरीवन अंडरस्टँड?
येस सर.
ओके, तर आता ही तुम्ही लिहून घेतली का सगळ्यांनी आता हीट बॅलन्स शीट लेआउट का नाही राहिला?
येस सर, लिहिले.
ओके, आपण पुढच्या क्लासला आपण कंप्लीट करूया. वाटलं जमलं तर मी काय करतो, ही पीपीटी करतो मी डायरेक्ट तुम्हाला, किंवा असं की जर जमलं तर पटकन होऊन जाईल. याची आपल्याला 1-2-3 गणित घेतली की आपला हा चॅप्टर संपतोय. एवढं अंडरस्टँडिंग? ओके, आता इथपर्यंत आपण राहूया. मी मग त्याला काय करतो, डिस्कार्ड कीप द चेंजेस म्हणतो. आणि आता पटकन फास्ट, तर मला मिटिंगला जायचं आहे का, तर एक अटेंडन्स एक 5 मिनिटात द्या तर बघा पटकन. 1 मिनिट. टुडेज डेट इज 8. मी तुम्हाला नोट्सची स्कॅन कॉपी पाठवतो, म्हणजे माझ्या नोट्स ही मागाची जी मुलाची नोट्स आहे त्या पण दुसऱ्या विद्यार्थ्याची आहे, दुसऱ्या कॉलेज. तर माझ्या विद्यार्थ्याची नोट्स मी तुम्हाला स्कॅन करायला चालू आहे माझं काम. मी तुम्हाला 1-2 दिवसांनी पाठवतो. रोल नंबर 1 to 10 फास्ट अनम्यूट का व्हा.
रोल नंबर इज प्रेझेंट.
रोल नंबर 1 प्रेझेंट, 2 प्रेझेंट, 3 ॲबसेंट, 4 ॲबसेंट, 4 ॲबसेंट, 5 ॲबसेंट,
6 present.
6 प्रेझेंट, 7 ॲबसेंट, 8 ॲबसेंट, 9 ॲबसेंट, 10 ॲबसेंट, 11 ॲबसेंट.
11 present.
ओके, 11 प्रेझेंट. 11 to 20. ओके, 11 is fast, no problem. 11 to 20. हा, फास्ट.
19 sir. Roll number 9.
ओके. 12 ॲबसेंट, 13
14 sir. 14.
13 प्रेझेंट, खडके. 14 प्रेझेंट,
14 sir.
14 प्रेझेंट, 15, 16, 17,
17 present. 17 present.
17 प्रेझेंट, 18,
18 present, sir.
18 प्रेझेंट, 19,
Yes, sir.
19.
Present.
ओके, अजित
Hi,
प्रेझेंट.
sir.
ओके, 20. ओके, अजित I know. 20 ॲबसेंट. 21 to 30 अनम्यूट. 21 to 30 अनम्यूट.
22.
21 ॲबसेंट. 22 प्रेझेंट. 23 ॲबसेंट. 24 ॲबसेंट. 25, 26, 27, 28 प्रेझेंट. 28.
Present.
ओके, 28 ऋतुजा कापसे प्रेझेंट. ओके, गुड. 29,
30 present.
30 प्रेझेंट. 31, 32, 32 ॲबसेंट. 33 ॲबसेंट. 34 34 प्रेझेंट. ओके, 34 प्रेझेंट. 35.
Yes sir. Yes
Yeah, okay, Shubham. 36, Shubham, I got 36, 37, 37, 38, 39, 40, 40, 41,
Present sir.
41 present. 42, 43, 43, 44,
Present, sir.
44 present. 45, 46,
Yes sir.
46 present. Okay. 47,
47. Yes sir.
okay. 48,
48 present, sir.
okay. Ajit, good. 49,
48 present.
48 present. 49, 50, 51, 51, 51, 52,
53 present.
53 present. 54, 55, 56,
57 present, sir.
57 present. 58.
Yes, sir.
59.
58 present.
58 present. Okay.
59.
59. Okay, present.
Present, sir.
60. 60 is 59 present, 58 present. 60.
61 present,
61.
sir.
62.
Yes, sir, present.
62. 61 present. 62. 63. 63. 64.
65
65.
present, sir.
Okay, 65 present.
Yes, sir.
66. 66. Kunal, I know. 66.
67.
7 present. 68. 68. 69. 70. 71. 72. 73. 74. 75. 76. 77. Okay, good. Thank you.
Hello, sir.
Ha.
The roll number 3.
Roll number 3. Who is your? Why you are giving attendance list? Okay. Anybody? Anybody? सर एकच मिनिट